This tutorial describes how you can open 3D datasets in the Baxter algorithms. In a 3D dataset, you acquire multiple 2D images at different z coordinates in your sample. And you can either save these 2D images as individual TIFF images or as TIFF stacks, where there's one file for each time point. So this dataset has z stacks, and if we open one of them, we see that there are 31 2D images in this stack, and we can go between the different z coordinates by clicking these buttons in the Windows player. And if you save your z slices as individual images, you will instead get something like this with many more images, where each image corresponds to one z coordinate. So here, for example, is time point 4 and z plane number 28. And if we open the first stacked experiment, where we have z stacks for the time points, we get something like this, where the first z slice is shown in the preview. We need to specify the number of z stacks first. In this case it's 31. We don't need to bother about the settings that are changed when you go from 2D to 3D. But we need to set the z-stacked parameter to 1 when we have a z-stacks in the dataset. So we save these settings, and then we see a maximum intensity projection in the preview. We can open the player to look at the maximum intensity projection, and given that this is a time series, we can play it. We can also zoom into the data, or we can look at the individual z-planes of the z-stack. If we uncheck the z-projection checkbox, we can use this slider to go between the different z-planes. We can also display other 3D views. This is the maximum intensity projection through the y dimension of the z-stack, and this is the projection through the x dimension of the z-stack. Here we see that the embryo is flattened, and that's because the distance between z-planes is much smaller than the distance between pixels in the 2D images. And this means that the voxels of the 3D data are much higher than they are wide, and we need to specify this in the settings to make the data display properly. So we go to settings, and we look at the voxel height parameter. This should be the ratio between the voxel height and the voxel width. And in this case, the voxel height is 1 micron, and the voxel width is 0.09 microns. And that gives a ratio of 11.1. So I enter that and save it. And then if I open the player again, the scaling in the 3 dimensions are correct. This is what I was planning to show in the 3D viewer. And I'm also going to show you how to open the dataset with individual 2D images where the TIFFs are not stacked. So we go to Open Experiment, Browse, and select that experiment. In this case, the program will interpret the dataset as a time series with many images, and we can use the same settings for the stacked data, but we need to set the z-stacked parameter to 0 instead of 1. So we reuse the settings that we used for the stacked TIFFs. We go to load settings and we find the settings file in that experiment. We load all of the settings and then we go to settings and specify the z-stacked parameter as 0, and then we get exactly the same result as with the stacked TIFF images.